This is part 2 of our Pragmatic Python series for the Spokane Python user group. The goal basically to help build your Python skills, kind of introduce you to some concepts and different tools available in Python itself. This is the second one, Journey to the Pythonic Peak, with a sick emoji. Yeah, Pythonic being kind of writing good Python code. And we'll talk about a little bit what that means in the next slide, but just welcome. I'm Joe Riddle, you all know me. So this is exciting, next month's topic, and anything, this is the working name, but I think we're gonna stick with it, an anything but mundane intro to machine learning by Clayton, who's gonna do an excellent job.
Might be very mundane, we'll see.
I asked him for a word that started with M, and he said mundane, and so I went with it. It will not be mundane though. He's been working on it already, and I think it's gonna be pretty good. Set the expectations high, pump them up for you. So this will actually be the first time I'm not presenting, and since I started doing the user group, which I'm super excited for. Either you guys have both been to this, I think your second or third time now. So, hey, how you guys doing? Good. Oh, you messaged me online, right?
Is that you?
Yes, sir.
I'm Mike Beecher.
Mike, nice to meet you. What's your name?
AJ?
AJ? Oh, sorry.
You are 12?
Cool. Okay, yeah. I remember Mr. Reed. Grab a seat. We're just getting started here. If you need a plug-in, you can probably grab that one on the corner.
Charged up in the switch.
A little bit. Oh.
You want to plug in while we switch hosts? I'll come over here. Okay.
Now, you're sitting right next to me. Do you mind if I get some mask down a little bit?
I'll pull a chair over and sit.
We got, you guys want water?
We got an extra one here.
We got some food in here, but the beverage is over there.
Okay.
Okay. I appreciate it.
Cool.
You can sit here, sir. No, you don't. I got an extra chair for you.
I'm sorry we were late.
Oh, no worries at all. No worries at all.
Yeah, we just got started.
Yeah, we're just getting going. We were just introducing Clayton, who will be doing next month's presentation on machine learning. And actually, I think it may be a good thing to do since we are kind of in a little bit more informal setting. Everyone, maybe want to go around and introduce just their name and what they do. I'll start. I'm Joe. I work here at Intelitech, software engineer, and I'm here because I'm the host and organizer.
I'm Clayton. I work at Intelitech too. I'm a data analyst, and I'm here to support my friend Joe and learn some Python.
Thank you.
I'm Nicole. I'm a communication specialist and work primarily with marketing here, but I've started to do some more very early beginner web development stuff, so I figured I'd show up and see what I could learn.
I'm Corey Farmer. I don't work here, but I do some game design stuff here and there with Unity, C#, and Java.
Hi, I'm Meg. I work here at Intelitech. I'm a software engineer. I am primarily the C#.NET developer. So I don't know anything about Python, which this will be fun.
I'm Phil. I work at Intelitech. I do lots of different stuff.
I'm AJ, and I'm a 6th grader. I've been teaching Python for about a year.
I'm Mike. I barely know what Python is. I'm in the Air Force. I'm the senior list leader in the aircraft maintenance squadron over at Fairchild Air Force Base. I'm here to support AJ.
I'm Adam Lutz. I also have a background a little bit in Unity and Unreal and game engine, working in game engines, but mainly I'm here to see what I can learn and see if I can expand on my skills.
Cool. And we have a couple people online. If anyone online does want to introduce themselves, we'll just feel free to unmute.
Hi, I'm Bryce. I also work at Intelitech. I work with, I've recently worked with Meg. I'm currently working with Joe and Phil. Nice to meet everyone.
I'm Skylar. I work at Intelitech, and I am learning to sharpen my Python skills thanks to Joseph.
Cool. Thanks, guys. Appreciate it. Okay, backtrack real quick. This is the second meetup. just for our newcomers. AJ, was it?
Yeah.
Cool. AJ, this is the second meetup. You didn't miss much in the first one. Sounds like you've been using Python for about a year, so you'll be cruising right along, I think. I'm Joe Riddle, as I said. My friend here, Clayton's gonna talk about machine learning next month. And we do record these meetups. In the actual last month's recording is now on YouTube, I think as of this morning. So if anyone wants to go back and watch it. And there's also, I think there's 4 recordings on there. If there's other meetups from like this summer that you missed and want to check it out. And then one thing I'll do, because I forgot to do it last time, is my mouse. I'll drop the link to both the IntelliTech website, or the Spokane Python website into the chat. And that has links to all of the code samples, etc., as well as the YouTube. And so that's in the chat. It's pretty simple, SpokanePython.com. $12 a year, got some domain, good to go. Cool, so just a quick review of like what I mean by pragmatic that we covered last time. The definition that we landed on was dealing with things sensibly and realistically in a way that is based on practical rather than theoretical considerations. So the main part of that definition that we're focusing on is practical. The goal of this series is to not just talk about how you might do something or the abstracts or maybe like high level math or something, but actually hopefully give you some skills so that when you walk away from these meetups, you can go and write your own Python programs, hopefully in a better way than maybe you were before, or at least know something new. The outline of what we're going to try and get through tonight, why Python. Something I didn't cover in last meetup was I talked about what Python was, how to get started. But if you're maybe more familiar, like Meg, with C# and PowerShell or any other language, and you're wondering why might I want to use Python, or maybe you're new to programming languages in general, wondering is Python like the one I want to jump into to get started with, we'll quick cover some reasons why you might choose Python. We'll talk about the Zen of Python, which maybe you haven't heard before. It's kind of where we get a little bit of our definition of Pythonic programming. We'll cover comprehensions, specifically list comprehensions and what that is, how to use them, exception handling, and like kind of flow control with exceptions. We'll talk a little bit about decorators. If you don't know what any things are, that's totally okay. We will try and get into generators and testing. We'll see how we're doing on time. That's kind of the outline. If you have a computer, the code repository is online and mostly up to date. So I don't think that you'll necessarily be wanting to follow along writing your own code. But if you want to, go for it. So first thing, why Python? Why might you use it at all or over different programming languages? Some kind of high level things. Python's really easy to read. If you've ever used like Objective-C or maybe like C in and of itself, it's very kind of hard to read. Whereas when you look at Python code, it's very similar to the English language. There's symbols, but there's less of them. So if it's your first time using a programming language, it's kind of that's a good reason to approach it. Another thing that's really a huge benefit is this concept of gradual typing. And apologies if I'm kind of going too fast. And what I mean by typing is in a language like C# or Java, everything is like typed, it's statically typed. So if you have a variable, even if you use like var x, where you're not var x equals 3, where you're not explicitly saying that this thing is an integer, it's still always going to be an integer. And if you try and assign it to something else, you're going to run into issues. In Python, you have a dynamic language where if you do x equals 3, and then the next line you do x equals like a string, that's going to be okay. But say you only want x to be an integer, you can do, I'll pull up exactly. Thanks, man. Yeah, and thank you for hopping in. Feel free to chime in, guys. Part of the goal of kind of having it in this room is to try and have it be collaborative and more of a discussion than a lecture or me just talking at you guys. So thank you, AJ. Appreciate it. Yeah, so exactly as AJ said, if we do x equals 3, or like I was saying, and then I do x equals a string, that's going to be perfectly okay. Whereas in C# you would run into issues, or in a statically typed language. But if I want to make x always an integer, this will actually work because Python doesn't enforce its type hints when it's running the code. It just enforces them like using like linters and stuff. So actually, let me open up VS Code and I'll show you guys what's going on here. And I'll create that soon. So here, if I do the same thing, I do x equals 3, and I do x equals hello, that's fine. But if I do y, and I using a type hint, like AJ said, do y is an integer, I use a type hint and make it equal to 3. And then if I do y equals hello, my linter is going to, in this case, pylance, is going to say, hey, you told me that y is always going to be an int, but you're trying to declare it to something that's not an integer. This isn't cool. And there's all sorts of tools that can check that using like static analysis, which is basically just looking at the code before it's run. And you saw in the idle that it's actually not enforced at runtime, and that's just kind of the way programming Python works, and as far as like type hinting works. In Python, you can provide type hints, but they're not actually enforced at runtime. And that's both a feature and maybe not a feature if you don't like the way that works. But I'm getting a little off track. Let's hop back over to the slides. And so I guess now that I've explained a little bit typing, what I mean by gradual typing is if you're starting a new Python project and you're just getting going and you don't want to worry about types, you just want to kind of write the code and worry about what the types are later, you can totally do that. And then what you can do is go back later as your project grows and there's more developers working on it, and you can start adding those type hints like the :in, and you can add those to parts of the code base and not other parts, and it just allows kind of rapid prototyping. Rolling on, Python is a very super wide ecosystem. It's been around for about 30 years, very commonly used for things like machine learning, like Clayton will talk about next month, developing AI, to use some buzzwords, but it's also used for really simple scripting, just automating things, web scraping, all sorts of stuff. And it being around for as long as it has and as popular as it is, there's packages out there for pretty much anything you would want to do. Another thing you might care about, especially if you are a developer, I think most programming languages are like this, but not all, is Python is open source. And for a long time, the inventor of Python, his name is Guido van Rossum. He was the BDFL, which stands for Benevolent Dictator for Life. And basically, he was the person who chose what made it into the Python language and what didn't. But it actually doesn't work that way anymore. As of a couple of years ago, Guido basically stepped down, and now there's a steering council, which is basically just a few people who all vote instead of just having kind of one dude in charge of what's going on. So in that regard, it's almost even more open source, I would say, than when it was mostly just Guido making decisions. And even when it was Guido, it was he had other people obviously involved and stuff. But a couple of reasons why to use Python. Quickly, maybe who uses Python in case you're thinking that no one uses it, or if you're trying to become a software developer and you're wondering if you should learn Python. It is very, very widely used. I think on Stack Overflow, it's consistently like one of the top 3 or 5 programming languages used. Google uses it. I mean, almost every like big company is going to use it in some capacity. I tried to highlight larger organizations that were using it for more specific reasons to Python. So in this case, a quote from a early on Google engineer was that their goal was to use Python where they could and C++ where they must. And basically what he meant by that is that because Python is an interpreted language, it is slower than a compiled language, or just a traditionally quicker language like C or C++ or Java. And that's a trade-off when you're looking at maybe using Python. If you're looking for like bleeding edge performance, Python might not be the choice for you. Guido worked at Google for a while. He also worked at Dropbox. So I just kind of show that like they're using Python and they got the guy who created it to work for them. They were doing something. A couple other notable companies, I won't spend much time on this, was Instagram. I think Instagram and Dropbox both built most of their like Dropbox built its desktop UI in Python. Instagram built basically its whole infrastructure in Python. I don't know if it's like that way anymore. I mean, I don't work at Instagram, so I only know that it was built like that because someone said so, but they could be lying. But kind of like I was talking about with the idea of gradual typing, we initially chose to use Python because its reputation for simplicity and practicality. So they chose it because it was really simple to approach, and they've been able to scale it over time I mean, Instagram's like huge. Spotify and Netflix are probably two of the most popular companies that use it for pretty heavy data analysis, machine learning stuff. If you check out Spotify's engineering blog, they have some really interesting stuff on like how they do the Spotify Wrapped at the end of the year, how they generate recommendations for what music you should listen to. And I think a lot of that is in Python. Cool. Moving on to the next high-level part of my outline, the Zen of Python. At the top of most of the slides at the start of a kind of a new topic, I've linked the PEP. What that means is Project Enhancement Proposal, and that's basically the method that Python uses to implement new things into the language. In this case, PEP 20 is called the Zen of Python, and it's only one small change. But what it is, or a quote from the PEP is, longtime Pythoneer Tim Peters, I don't know who he is, but I think he worked on Python. I know he worked on Python, but succinctly channels the BDFL, so in that case Guido's guiding principles for Python's design into 20 aphorisms, only 19 of which have been written down. I don't fully understand the 19 written down part. I think it's just a joke. But basically, all this means is that if we in our REPL do import this, we get these list of 19 different things that are going on in Python. So AJ, have you ever tried that? You import this?
I haven't done import this.
Yeah, so if you pop open your an idle or a REPL, or just like Nicole, I think you're running Python from the command line.
Yeah.
If you just do I can type import this, we get the beautiful Zen of Python. And beautiful is better than ugly, explicit is better than implicit. You might be wondering, like, what is this? Why is it in the language? Like, who would ever really want to look at this? And the reason that we're looking at it today is that a lot of the things that we find in here are kind of guiding principles when looking at Python code and determining, is this Pythonic code? A lot of the ideas that people consider Pythonic or well-written Python go back to the principles or aphorisms that we find in this. Readability counts, errors should never pass silently unless explicitly silenced. We'll go over some of those in later slides, but it's worth taking a look at if you've never seen it before, and it's kind of a little Easter egg that you can actually see it from the like Python interpreter if you just do import this. What was that?
That's really cool. I've never encountered anything like that in any language.
Yeah, it's kind of fun. It's the PEP itself, like the official like kind of documentation of it is like at the bottom. It's like, if you wanted to see a little Easter egg, just do import this, and hey, look, there it is.
Nice.
So moving on to sort of our first actual like programming or like writing code topic that's considered Pythonic. Is we're going to talk about comprehensions, specifically list comprehensions. And so again, I've linked the PEP that added list comprehensions into the language. I'll just read the quote real quick. List comprehensions provide a more concise way to create lists in situations where the functions map and filter and or nested loops would currently be used. I'll show so what a list comprehension looks like, and you've probably seen it if you use really any amount of Python for a little bit. Have you seen this before, AJ, like a list comprehension?
No, really.
Okay. Yeah, no worries. It's it's interesting. Basically, the reason that we consider list comprehensions arguably Pythonic is that they provide kind of this one simple interface to do a lot of really powerful things. So if we look at the syntax, we're basically seeing the ability to create a list out of like another list using like the same syntax all over the place. So in this case, we're doing basically a map operation on a list of users that seem to have an age property. And so we can create this new list, like this map list from our other list and like map the age property using this syntax. And so if we were to do that and we had a list of users with an age property, we would see we have some ages. This is kind of a trivial example, but if we take it a little bit further, and I'll actually pull up the code in a second, we'll see that if you have a list of users, and I'll look here really quick. So if we have a list of users, and each of those users have a list of friends, we can go not one, but two, like two maps deep, all in one line, or excuse me, not one line, but in one comprehension. And then we can also do filtering. So in this case, cool friends names would be any friends that are nested that are not Joseph Riddle. And then in this case, we would see if Phil Focus is cool. And I'll pull up the code really quick because we're not able to see quite everything that's going on here. Let's go. So what we have here is that kind of users class that we were just pulling out of the void in the example. In this case, it's a data class. All that means, if you're not familiar, is that it generates an init function for us. And so we don't have to declare that ourselves, but basically just a really simple model. Takes in a name and age and a list of other users that are the friends. You can see here we create a couple users, myself, Clayton, Phil, and their ages, which are super accurate.
Totally.
Yeah. We create a list of those users. Again, really pretty simple code. And then here's that example that I showed in the previous slide. We're creating a list of those users' ages, basically that property on the user model, by using a list comprehension, which is this syntax right here. And we're printing those ages. Now, if we were to say Clayton has a list of friends, which include Phil, Phil has a list of friends, which include myself, and then again, that syntax or that code snippet I was showing from the previous slide, you can see that we're not only iterating through our list of users, but we're also iterating through the nested lists within them, all in one code snippet. Now, you might be wondering, like, okay, like this, all you're doing is kind of like walking through like two lists. It's like not all that interesting. They're not that cool. But an alternative to another way you might do that using some other built-in functions to Python, which are map and filter. Map being grab this property from each model in the list. Filter being grab the objects from this list that match some filter to use the name of it in the definition. But to do, and this isn't necessarily the most concise way to do it, but I think it's relatively close. To do the same creation of this cool friend names property or variable that we did using list comprehensions, but not using list comprehensions. One way to do that is we have to, first we grab all of the user's friends, every user's friend. And so we're calling our map function once here. This lambda, this is basically just saying, hey, create a list of all of the user's friends. So at this point, we would have a list that includes another list of Phil and another list of Joseph, and then an empty list for my friends, because I guess I have none in this example. Kind of sad, but anyway. And then we have to do a for loop through each of those lists that we just created, and then we have to do another map to grab each of the friends' names, and then we have to do a filter to grab the friends' names that aren't Joseph Riddle. And then we're adding all of that because this object is actually not a list, it's a filter. But we're adding all of that to our cool friends names. So you can see this is we have some nesting going on, like we're inside of a for loop, and we have to do some setup before the for loop to create like our master list of cool friends names. And it's just like looking at this versus looking at that, like I know which one I would choose, and it kind of goes back to some of those lines from the Zen of Python, favoring like readability is important, and keeping things simple is also important. And so yeah, that's kind of some list comprehension stuff.
That's really cool. At first, my impulse was frightened that everything seems like it's upside down, because normally you're starting at your for loop, you start with your list and then your for loop, and then you go deeper and like you keep going down to what you need to get to. But this is awesome because what you're trying to find is at the top, so you can like stay focused on that, and then you kind of work your way backwards. So it's really an easy way to do it, like compared to having 20 indents,
Yeah, I'll say I kind of came from I hadn't really used Python all that much, like a year and a half ago or so, and I kind of came into a Python project from working with C#, which has link, which is like .select and .filter, and it's been so long I don't even remember what else. .where, it's like, and then like TypeScript, which also uses like I think it's like maps and filters, and kind of similar to the syntax down here. And at first I was like, I kind of missed this map and this filter and this list comprehension thing looks kind of weird. Like I don't really want to write it like this, but after having used it for a while, it's actually like pretty powerful. And we'll see in some later slides that this basically syntax of having like an opening, in this case brackets, and then like a closing one, and inside we have like this kind of concise for loop. This syntax is like used really well throughout most of the Python language, and it's pretty powerful. Yeah, appreciate the input.
So this isn't doing any reducing, right? It's just iterating.
So in this case, we are reducing, because that's a good question. If you were to do it this way, we have to first grab like that. We have to grab the list of friends, but then that's a list of lists. And so we'd want to reduce that down to like just a flat list of strings. And so what this allows us to do, basically using the for in logic twice, is we can grab our list of lists, and then we can like flat map that list of lists into just a flat list. So in this case, this is a list of friend names. So this would be every name of a friend from all of the users, instead of like a list of each user's friends' names.
At 2 levels.
At 2 levels.
And if the names are duplicated, you're going to have duplicates in the list.
In this case, yeah, I'm not.
If we share friends.
Yeah.
So you could perform an operation on the list after, I would assume, to reduce it, right, or eliminate dupes or whatever you want.
Yeah, and if you wanted to get like a unique list of names, there's other ways to do it. I mean, you could do a set, would be maybe the simplest way, and then you'll have a unique list of all your friends' names. There's probably several different ways, but yeah, in this case, if say you and Clayton were both friends with me, my name would show up twice. Cool. Good question. Thank you, Phil. Any other questions, comments before we hop along to the next topic?
Just only that I've written that map filter so many times that way, and I didn't realize that was
Yeah, definitely worth checking out. I will say, you can even do like, say, like real quick. I won't have a great example, but you can do like something equals 4x in list. I don't know. Say users, or user in users. You could even nest these if you wanted. I wouldn't recommend doing it though. I'm just like this. I mean, this isn't really showing what's going on, but you could do like for friend, like I think friend in user dot friends. Yeah. You can get some nasty syntax if you go too far with this. Like at some point, you probably want to create either like functions or just break it up into a full-on for loop. But it's pretty powerful, and it doesn't really limit like how deep you can go with the list comprehension. Cool. AJ, any thoughts, man?
No.
Right on. Cool. I like your shirt.
Thanks.
Cool. Let me hop back over. And people online, feel free to just unmute, and if I'm in the middle of talking, just interrupt. I know the online thing can be a little bit harder to jump in. So this would be, like I said, there's this same syntax of like having some opening thing, some opening grammar and some closing grammar, and then having a for loop inside of it. So if you wanted to create a dictionary or a dict from either, in this case, we have a list, and what we're doing here is we're just saying for every user in our list of users, I want to create a dictionary that has a key of the user's name and a value of the user. If you were doing something where it was, maybe you wanted to be able to look up a user by their name immediately instead of iterating through the whole list of users. This would not work, but this is just to show that if you wanted to create a dictionary using a comprehension from an existing dictionary, you can call .items on the dictionary and get, you would get back a tuple, which you can unpack the tuple to its key and value. And so if you were just to have for x, then x in that case would be a tuple with two values inside of it. A tuple just being basically an immutable list for the sake of this example. But if you're wanting to create a dictionary from another dictionary, this is a way to do it. Map and filter, we talked about. Simple is better than complex. This is, I think you pointed out, like you have been doing this for a while and would maybe prefer a different way of doing things.
I mean, it's really hard to read, especially once you get like, several scripts in.
Yeah.
And you're trying to like pull from one and search for another one, and
yeah,
it gets really complicated.
Yeah, I hear you. One built-in Python module that is definitely worth taking a look at, especially if you're doing a lot of like list operations and like a lot of like working with, collections of objects, is itertools. If you haven't used it before, it has a lot of really powerful, like well-tested functions for combining, like if you want to walk through two lists at the same time, so you have like a list of users and a list of groups and you want to walk through them in unison, there's that itertools.zip will allow you to pass in like multiple iterables, so like multiple lists or multiple sets, and you can walk through them in unison. There's a ton. There's like flat mapping stuff in there if you don't want to use comprehensions. And you can use the itertools with comprehensions. The two are not like mutual. Definitely a module or a package I would really recommend like taking a look at. Cool. Next kind of topic from the outline is we're just going to talk a little bit about exception handling in Python. So this is taken directly from that Zen of Python, or the import this. Errors should never pass silently unless explicitly silenced. So it's like, okay, cool, dude. Like, that doesn't make any sense. What does it even mean? And I don't actually know like exactly like what the intention was behind it, but I can kind of surmise from my own experiences. One thing you really don't want to do in Python is, well, actually, we'll skip one slide forward and I'll come back. Don't do this. Don't catch exceptions and just like ignore them. Like that's, if you're not handling an exception in a way where you're doing something meaningful, then that's not really a great coding practice. I'll be honest, I've done this in code myself sometimes, where it's like, okay, like I expect this thing will sometimes throw an error, and I'm just gonna like catch the error and kind of just like silence it, or just like throw the error in the trash. Like I don't care about it at all. And oftentimes, like most of the time, errors are there for a reason, and you should do like something meaningful, logic-wise, with that error. And just like this is something I've done before. I really don't recommend it. But something actually even worse is if you do this. Now, the eagle-eyed observer will notice it's slightly different. In this case, we're catching this exception called base exception. Basically what that is like, if you just do except, and if you don't even, you can just do except : and not even have anything. And that will basically catch a type of error that's one level down from like the built-in, like the top level error in Python. So errors, the way they work in Python is it's like an inheritance, like every error kind of inherits from some error above it, and they all inherit from base exception, including things like the program trying to end using like a system exit, including like a keyboard interrupt from the user. And so if you're catching this exception, you're basically catching everything, even things that you are almost certainly not going to handle. And so the idea here being only handle errors if you're actually going to handle them. If you're catching just like all the errors and not doing anything with them, that's not the move, and you're going to run into issues. I've had like background tasks running where I was trying to kill them from the command line, and I had accidentally like written similar to this line of code where I was handling, or I was doing like accept base exception, and I couldn't kill the background task from the command line because when I was like trying to send a keyboard interrupt, it was just like, oh cool, I'm gonna keep like rolling on. And, it was kind of a nightmare, and so I realized what was going on. Just to show you, I'll come back to this in a second because this is something to do with exceptions, but slightly different. It's not that. This. So we will. I guess that the repo online is not totally, but I'll update it after the presentation. Exception handling that. Oh, here we go. Okay. This, we saw that in the slide. So here is a function that's going to print, I can't die, it's unkillable. And then it's just going to sleep for a second. That's mostly so that when I run this, my console doesn't just get immediately filled with I can't die messages over and over and over. And then it's going to raise one of those errors that inherits directly from our base exception. And if you look at actually some other exceptions that are built into Python, like attribute error or key error should be here somewhere, really common errors that you're gonna handle frequently in your code base, you'll notice those all inherit from this exception. They don't inherit from the base exception. But things like keyboard interrupt, system exit, those inherit from this top level base exception. And so when I handle that down below, and I kill that, and I navigate into my samples, and I do Python exception handling bad, you'll see, and if I do Control C, you'll see I cannot kill it. I guess viewers at home cannot tell what I'm going on, but I'm viciously pressing Control C. And so it's basically just eating this system exit error. And there's nothing I can do about it, except just close the whole thing. And so that is just a real world example of why you should be selective about what errors you are handling. But backtracking just a little bit to the first slide, which I glanced over, here we have two snippets that look virtually identical, except for just like one or two little pieces. They're both a function that's GetUser, looks like it's taking in a name and trying to find a user with that name from some property users by name. So in this case, and we can assume this is a dictionary or something that can handle this syntax. In this case, we are using the braces, brackets. I should know this. Yeah. Phil knows. We're using the brackets and we're passing in name. And basically, if this is a dictionary, what we're going to see is, and you can tell by our type hinting, like AJ pointed out earlier using type hinting, this is always going to return a user. This might return a user, or it might return nothing, none. Basically, the equivalent of null in like C# or another programming language. And the reason that we want to usually lean towards using this sort of syntax versus this is that in this case, if our user doesn't exist for whatever reason, or that name doesn't exist in our dictionary, we're going to get an error. In this case, it'll be I believe a key error that the dictionary is going to raise because you're trying to grab a value using a key that doesn't exist in the dictionary. Whereas in this case, just because we're using a slightly different method, we're using get with a default of none. Basically what that's going to do is say, okay, if this name doesn't exist in the dictionary, return this default value of none. And basically what we're doing in a way is we're handling that error kind of in line. We're handling the fact that if this user doesn't exist, then we're just going to return none. And we're doing that like right here. But what happens, and I'll pose this question to the group, what happens if we use this code in the code that's calling GetUser? What do we have to do now when we pass in like GetUser Clayton, and then it's equal like some result? Like what do we have to do with that result to use it?
Not sure.
Thoughts?
Check it for none.
Exactly. Thank you, Phil. We have to check it for none. And then what happens is everywhere we're using this is we're now checking for none, checking for none, checking for none. And we have to just do that all over the place. All these different like none checks or null check would be kind of the same phrase. And that kind of leads to some relatively harder to handle code when you're doing a none check. You never know, hey, is the thing I'm getting back actually what I expected? Now you might kind of say like, okay, but if this just raises an error, isn't that kind of almost worse? Like now my whole program is just going to crash instead of just getting the none back. But what it enables you to do if you return or let the exception basically bubble up or go up to the next level, the function that's calling this function, is that function can choose to handle the error, or maybe you do want it to just error out if that user doesn't exist. Maybe it bubbles it up to the grandparent function, like whatever is calling the function is calling this function, and that function chooses to handle it. Basically, bubbling up the errors allows you, as the caller of the function, to choose how you want to handle the fact that that user doesn't exist. And you can still do that doing like a none check, but then you have to kind of like write that code everywhere. You have to do like if, not none constantly, and it just kind of gets a little gross. Okay.
So I'm just curious about shorthanding this. So I know C# has like a coalescing operator where you know the double question marks. I don't know if you're familiar with that.
Yeah.
Yeah. Does Python have something similar, or do you have to wrap it in that like if block? Do they have any like shorthand?
As far as doing like a quick null check.
Yeah.
Excuse me. There is, I think, one or two different ways you could get around it. So if we were to do,
What does the double question mark do?
So like if something was null, I don't really have an example, but if you have like a variable that's null, the double question mark is like if null, do this.
Oh, gotcha.
It's just a quicker way of doing the if.
Gotcha.
well, here, I guess I just.
Which I don't want to sidetrack this.
No, you're good.
conversation.
That's a good
If
question.
you don't know off the top of your head, I was just curious.
So you can do user, you can do none or like, hello? So x equals, so basically what this would do is if the left, oh, sorry. So if the left operator, like if the left value of the or is falsy, not none, but falsy, and that kind of like JavaScript where 0 is falsy, or I don't know if it's exactly the same in JavaScript, like an empty string or an empty list is falsy, then it will go to the, like basically the right of that. And you could chain a bunch of these, and none could actually be like GetUser, and then you could do like, or create like a default user, and this would be like whatever. Okay. So you could do something like that. You do want to be kind of careful because, like I said, like it's not a none check, it's a falsy check, and there might be times where maybe you're expecting an integer back, or where you're getting a result that could be none, it could be 0, or it could be some other integer, and you want the 0 if it's a 0, but you don't want none. And that's where you can actually do something that I don't really like. It like get user if get user is not none else user.
Oh, interesting.
So it I'm not really a fan of this syntax personally. I don't really use it. It's kind of hard to read, and I don't like it as much as doing x equals like true, like in JavaScript, else.
Yeah,
whatever.
That's what it reminded me of.
Yeah, I can't remember what this is called off the top of my head, but Not the null coalescing operator, but the ternary expression, I think is what it's called.
Yeah.
So it's kind of similar to like a ternary expression. You might even actually call it a ternary expression, but I don't like it because what happens is you have a value on the left, you have like a conditional check in the middle, and then you have another value on the right. And it just reads very weird to me. But this is a way to kind of one line set a value where it's always going to be like a not null or not none. Sorry, you were going to say something?
No, I wasn't.
Oh, okay.
It seems better just to do it in the if. It seems it's like the best practice.
Yeah, I mean, if
Or
you're
explicit, I mean,
Yeah, which I think is.
that can get nasty. I think also there's an implication of what's going on in GetUser. You know, and it pays to be explicit.
Yeah. And in this case, like this, I guess, and you could rewrite it so you don't have to do this, but in this case, you're calling this function twice. You're calling it once to look at its result, and then you're calling it again when you choose to get the result.
Mhm.
There is something new in Python 3.10, which I haven't really used. And feel free to grab food, guys. We have a bunch. It's called the walrus operator, and I haven't used it, so I might get the syntax slightly wrong, but it looks like a little sideways walrus. And I don't even know how it works, to be honest. I've only looked at it like once, but I don't have 3.10 and I haven't used it. But I think it's very similar to a double question mark. But something to look into if you're using 3.10, which is the latest Python version.
Isn't that like blasphemy for Python since they use word literals as their?
Well, I mean, true. I mean, we have the equals up above, and you can do things in Python like this. Like you can do that, and that will do like if x was a number, it'll do it. But yeah,
Okay, they
it's a
still
fair
do
point,
have some
yeah.
operators in there. Gotcha.
And then, I mean, and it introduces, like one of the things in the Zen of Python is there should be one and only one way to do something. And now you have this new syntax, and that's where some people do get into some relatively heated arguments. I think, actually, this is just something I heard the other day in a podcast, was Guido, the benevolent dictator for life, actually stepped down after the PET, or the project, like the thing that added the Walrus operator to the Python language. After that got submitted and pushed through, like Guido approved that one and like basically said like, okay, like we're gonna add this language, and then he stepped down. And for whatever reason, this simple like syntax change generated such like a hot debate of people on the Python internets that I think he just decided, and maybe he was already planning on doing it. I don't know if it was exactly this, but from what I understand, like there is some sides drawn for this, like whether this should be in the language or not. But it is, and it's in 3.10, so you can use it.
Gotcha.
What is the walrus?
So you don't have to use it.
Or yeah, you don't. Yeah, and that's kind of his argument. Yeah, you don't have to use it.
Don't use it if you don't want
What
to.
does it do?
What? And that's what I'm like. I haven't used it, so I don't really have a great answer for you, Nicole, because I can't remember exactly.
Well, I just typed in following what you're doing, and I kept getting errors.
So you actually
have to upgrade your Python if you're at .9.
I downloaded it today.
Oh, you're at .10?
She has.
Okay.
Where am I at? Yeah, she has 3.10. Let's see if this shows us. This exactly the same. So I think it's like the double question mark. It only assigns the value if the value is truthy. So in this case, if you entered in an empty string to input, so input takes like, you type in a response on like the command line. If you enter in an empty string, it's not going to assign it.
I'm reading here, it says it offers a way to assign variables within an expression, including variables that do not exist yet, which I assume means that they're being evaluated within that expression. So it's like, I don't know.
Yeah.
Yeah.
I don't know. Sorry, I don't have that. Yeah.
I don't know. I'm not sure it is.
I mean, if you're reading it online, it's probably true. Everything you read online is true. I think its goal is just so you don't
Everybody
have
agrees online too, which is always nice.
Yeah.
Yeah.
You always get the same story no matter where you look. That's just beautiful.
Yeah.
Great thing about living in our age.
Yeah, walrus operator. I don't remember what your question was. Is there an easier way to do this? And I think the walrus operator might be an answer.
Cool.
As well as those other two syntax syntaxize.
I apologize for sidetracking us.
You're totally good. I mean, that's kind of like why I wanted to be in the room where we could talk and have discussion. Now everyone knows what the Walrus operator is. Well, not really, because I didn't really explain it, but you explained it.
Yeah, I read the definition on Google
Yeah.
from the first link I saw.
Honestly, if you guys are ever like wondering, how does this thing work? Like, how do list comprehensions work? What I like to do a lot of times is I Google site:python.org so that it's only like the official Python documentation, and then I just type in like list comprehensions, and more often than not, you'll see the actual PEP, the things that I'm linking to, that talks about like, hey, here's what the motivation was to add this to the language, here's how it works, here's some examples. Like, it's like the source of truth for how something works, unless they're out of date, or not out of date, but if they've been like replaced or removed from language. But I don't know, it'll usually say. Cool. Any other exception handling questions? I mean, AJ, questions? AJ's dad, whose name I forget, I apologize.
Mike,
Mike.
I understand most of the words you're saying. Not all, but most.
I'm on the same page. I don't know.
No, I'm enjoying it.
It's like, welcome to a day in my life.
So Nicole mentioned up front, she's in marketing and sort of dabbling in dev stuff. And she walks up to me the other day, and Nicole, I hope you're okay with me saying this. And she's like, I keep having to Google things, and then I ask one of the devs next to me, and they don't know. They say they have to look it up. And she's like, does anyone know anything? And I was like, no, that's what being a dev is. You're always looking stuff up because everything is a new challenge.
Yeah, you're hired based on how well you can Google something.
Yeah, how well you can copy paste from Stack Overflow. No, I'm just kidding. If there's any customers listening, we do more than that. Cool. Okay, we're at 6:57, and I will try probably not to go too much past, like, I don't want to go past 7:30 because it's late and it's winter, and yeah. And because my last slide isn't totally finished, so I'll just use another excuse. No, but I'll keep going for at least a little bit longer. But yeah, I think last time people weren't out of here till after 8, but I'll cut it short tonight. So the final thing I will talk about is this thing called decorators. And again, the link to the PEP is in the slides, which will be available online, are available online. They're available online for the previous meetups. I don't know if this one is yet, but anyway, syntactic sugar for wrapping functions with a reusable logic. So the first thing you might be wondering is, what does syntactic sugar mean? That sounds made up. Sounds like kind of a buzzword. I don't really know what it is. And basically, I mean by syntactic sugar, and I didn't come up with that phrase, but is like the language is doing something for you that you could do yourself also in Python, but it just provides kind of a cleaner interface or a cleaner way of writing it, where it does some magic behind the scenes to kind of change the way stuff is working. And I'll show in a sec kind of how the syntax works.
Is list comprehension an example of that?
That is a great question, and I don't know. That's a good question. I don't actually know what list. I mean, if you're using CPython, which is what like Python gets compiled down to, then everything in a way is like syntactic sugar. No, I mean that's not the same. I don't know. It's long story short.
Okay, yeah.
Or short story long.
No worries.
That's a good question though. Cool. So decorators. So say we have this function square. All it's doing is we're passing in x, a number, and we're returning so star is just like to the power of in Python. And so in this case, if we pass in 2, we get 4. You'll notice that this function is just returning a value. It's not printing anything. It's not doing any side effects, as you might call them. It's just computing the mathematical formula and returning it. And then here we have this function we call log. And we see that it's taking this parameter or this argument func, short for function, which is what def, etc. is. It's the function in Python. And you'll notice that inside we call the function and we print the result and we return the result. And I actually think I messed up here because this will not work. But in my VS Code, I think the right syntax. Yeah, I don't think that will actually work. Actually, let me pull up VS Code really quick. Apologies.
So the asterisk, that's just to the power of any number. So whatever number you put after your variable is what you end up
Say it one more
So
time.
like if you put x asterisk asterisk to the third, it'd be x cubed.
Exactly, yeah, so you get 8.
I assume you can't do those strings.
I don't know what would
I don't know,
happen.
though, I'm probably just throwing error.
So actually, so I guess you could call this, kind of going back to that idea of syntactic sugar, you could call it star syntactic sugar, or saying that object has implemented the dunder power function. And what I mean by that is dunder in Python is like 2 underscores. And so like dunder init for an object is like when it gets created, like that gets run automatically. And a way that a lot of the stuff in Python works kind of under the hood is that you just implement these dunder functions, these like basically function names that are reserved for like the Python operating language, for the Python language. And by implementing those, you enable sort of this syntax. And so I guess a more simple example of that would be numbers like 2 + 2 in Python is, I believe, under the hood just calling dunder or underscore add on the int object. And I guess that goes to everything in Python is actually an object. I think you come from like C# or something, your ints are a value type, not an object. In Python, everything is an object, which actually adds to some overhead, but helps simplify some things. I won't get it. We're kind of getting off topic. I forget what the original question was, but yes, the star 2 3 would give you 8. And I'll pull up VS Code in a sec. But what I was trying to show here is basically, you can see we define this function. Like I said, everything in Python is an object. Functions are also objects that you can manipulate and change. And so we change our square function to actually be log wrapped around square. And so basically the goal there being, when I call square, I want to kind of implicitly log that result of square out to, in this case, it's just printing it out. And this is basically what a decorator does, but it gives you kind of some more syntactic sugar. I didn't think I was going to say that as many times as I have, so apologies if I keep saying it. But let's go to the next slide, because I think it actually shows what. So if we were to take this with one tweak, which I'll pull up after we get through the decorator slides. So the PET 318 introduced this syntax. And syntax, I guess if I didn't find that syntax being just the way that it reads the language. So now, if we think back to the last slide, we defined that log function, which took in another function, ran that function, and then printed out the result of the inner function. Now, instead of basically having to redefine square twice, because we did def square, and then we assigned square equal to our log function calling square, now we can just do @log. I've heard this called the pi symbol. I've never called it that, but that's just something I read today. I don't know why. Anywho, so now if we do @log, log or any other function, basically being a function that takes in another function, we can do this and we get the same thing. You'll notice when we call square, again, we're not printing x anywhere within our square function, but it's still getting printed out. And so you could also use @log with, say you wanted to do like def cube, and it was just x cubed, then it would also print that out. And basically what this gives you is this reusable function, and this reusable component that you can use across your code base to do like, I mean, you can do anything, but like some side effect or some kind of utility, like logging it to a file, or maybe you want to time how long some of your functions take to run. Maybe you have, instead of def square, it's def do really long thing that takes forever. That'd be a long function name, but you can still do it. And so maybe you want to do @time it, and I think that's actually one that's built in the Python language if you go looking somewhere. And it automatically times how long that nested function took to run. Am I explaining this in an okay way that everyone's tracking? Okay, cool.
Couple of questions. Couple of questions.
Hit it.
So the decorator has some context, I assume. So in a case of logging, I mean, this is a classic case where you would attribute you use an attribute.
Not the same.
Sorry, that was a different one.
So, for example, if I was logging, I don't want to just log the result. I might want to have some other attributes like the daytime, the method, maybe some other properties from the method that I want in my log.
Yeah.
Right. So yeah, I'm not going to put that on every function I write, but I'm going to put it on any function I want to log, quote unquote log in my.
Yeah.
In my,
So the question is like, can you do more than just basically handle the result of the function? And all right, everyone's catching.
Sorry, I was ready for it.
No, you're good.
My phone does not let me mute them.
I don't know if mine does either.
Mine doesn't either.
I'm just gonna say mine doesn't because it went out. So it's been on Apple.
And then I've got another question for you after that one.
Okay, so first answer is yes, you can do whatever you want within the language. So here.
Because you've got function has properties. You could interrogate function for whatever properties and use them in your function. So I see def log func.
Well.
And maybe don't let me answer my own question. Go for it.
No, you're good. So my understanding is you're asking like, can I do like other side effects than just basically like grabbing the result of the function? And if I'm answering your question, the answer is yes. Like you could log out. I mean, you could create whatever objects you want here, like in this context. Like you basically have access to it within this decorator function. You have access to before the function runs and after the function runs. In this case, we're not doing anything before the function runs, but after it, we're just grabbing the result. So you can really do. I'm not answering your question.
In my result, I want the function name.
Yeah, you could do that. Yeah, you could do. I think you could do func dot under name might get you the name of the function. There's definitely introspection tools that are pretty available. And I haven't done a ton of introspection in like C#, but because of the way Python works, like nothing is really totally hands off. Like I think in C# there's like some things that are pretty hard or nasty to grab, like kind of low level. But in Python, everything's there. Like now, you shouldn't necessarily change things that are considered private. Private being like if it starts with like a single underscore and then it's like a variable name, that would be like kind of indicating, hey, this is a private class property or class like method. But you can still go do it.
Yeah, it's a convention versus a rule.
Exactly.
I mean, C# is that way a lot these days.
Yeah.
As well.
I don't use it anymore. I don't know.
The next question I have for you is on scoping.
Yes.
So I got square equal log square.
Yes.
What? So I've got def square. Why doesn't square just replace square? It seems like that would do something really nasty there, like square, setting square equal to the log of square. Now I've got square should be calling log. How can log of square just call square, not the square that's logging square?
I know. I think you lost me. One thing I'm gonna do.
So you have defined square.
Let me pull up
as a function.
I think there's a bug in that code,
and then you set square equal to log of square, which would replace the in my view, replace the function.
Please.
Okay, so let's just
what's that
from the top. So first we define square. We call square. Cool. Without using any syntactic sugar, we define log. And this is I didn't realize I didn't update it in my slides, so apologies for that. This is actually like the proper inside of log that you would use, and I should have hopped over to this from the beginning once I realized that it was wrong. But basically what you're doing inside of here is you're defining a wrapper function, like a nested function, which you pass func's arguments to. So in this case, func being square. And then you return the result from your the function you're passing like normal. You do any like decorator side effects you might want to do, like print the result. And then you're basically replacing this originally defined square function with this new function that wraps around your square function.
How does it know that the square that you passed in is the original square and not the square that has the wrapper, that has the decorator?
I don't think it does. I think he was just.
Oh, wait a minute. One has a U and one doesn't. No? Yeah, they're both square and square.
Yeah, so this is the same thing. It's just complaining because it doesn't like that I'm redefining this, which is fine. You can do it. It just doesn't think that it's.
But how does it know?
Top down, right? Python
Yeah.
needed to be functional with top down.
Well,
The other square was first, right?
yes. So if I do,
So because when I say square equal to log of square, it knows that that square is, it's the one preceding me.
yeah, so basically,
Got it. So but I couldn't call that square again
Right, it's over.
from following code. I could only call that square from earlier code. Got it.
before it gets reassigned.
The same as like x equals x plus 1, right? Same idea. Overwrites it.
Yeah, but now x plus 1 is forever changed. So in this scenario, basically what we're saying is I never have another shot in the rest of my code of calling the original square.
I
Got
think the complaint is that you shouldn't be doing that on line 19. Unless you intentionally want to overwrite your functions, you should call it, I don't know, like.
Yeah, it sounds like there should be like a convention for
We're good.
No more red squiggly, rock and roll.
That's all that matters.
just underscore squares the def of the function, and then when you actually create your function, just square. I don't know.
Yeah,
Like a good
well-
way to like do the syntax on this, like would you not like want to say like, oh, like square log or like log square, and then like I don't know, overwriting it seems.
So like this, or
I like that.
so like here, we're basically doing, we're just defining. So assume nothing up here exists. Well, sorry, assume this doesn't exist. We'll just comment it out. It's fine. It's fine. We'll just comment that all out. I don't know. This is complaining now.
Too much count? Oh no.
No, it's because I've defined everything like 50 times in the same file. There we go. Now square is defined once. And only once. We're not doing, like we were before without our decorator, our syntactic sugar, we're not redefining square. All we're doing is adding a decorator, which is basically just a reference to this function. And what this is doing under the hood is like pretty much, maybe not like line, like word symbol for symbol, but it's basically the same as, line 19, where it's just saying, okay, now my square function is actually a reference to this wrapper function that calls the square function.
So
Like the key thing here is that Python is interpreted. It's not like a multi-pass compiler, not multi-pass compiled.
Moral of the story is to do what you're doing on line 24 and not what you're doing on line 19, I guess. Which is, I think, what you were trying to get at.
Well,
It's a good example. It's a very good example.
From a code readability standpoint, yes. From the way it's actually going to work, line 24 is going to basically do what line 19 is doing.
Yeah. But like readability and like avoiding confusion. Like,
Yeah, and
that looks a lot nicer to me.
And you have, so in C# you can do like at whatever. I don't know if it's also called a decorator, but you can add like, what are those called?
What is it?
Is it
Attributes?
attributes? And I guess that's different because that's not like wrapping around the whole function.
It's adding behavior to a function.
And this, I mean, I guess this is kind of doing the same
Yeah,
thing.
it's similar.
Yeah. I don't know how C# does it then. If hooks, I don't know.
You gotta get this, go to the
That's
class
what the-
next, go to this next C# meetup and ask one of the C# experts.
The .NET
I
meeting.
wrote a book, but it was 20 years ago or something. So,
I didn't know you wrote a book.
yeah, 1990, what year is it? Or 2000, I don't even know when it was. It's so long ago, I don't even know when it was. 2000. What year is it? 2021?
Before the millennium.
Before the millennium, Austin says. I think that's Austin.
So, and a lot's changed in 20 years. That's my excuse. Plus I'm old. That's my other excuse. And I forget stuff. Do I need more excuses or are we good?
No, we're good. We're good. 7:15. We'll try and wrap it up pretty quick here. You might be wondering, what if I want to do like I want to log this thing more than just once. And this is kind of a contrived trivial example, like just logging something like 3 times is not necessarily like a super interesting use case, but imagine something more interesting. You might be wondering, like, what if I want to I want to configure my decorator to do something where it's like it's kind of its logic is the same, but it's just I'm tweaking it a little. Like I'm passing it arguments. And so, long story short, you can do that. You just have another level of nesting, and this does get, I guess, a little bit gross if you go back to the Zen of Python. The idea is that you're kind of hiding you're hiding the grossness so that you can use this in your like kind of more normal code and it looks good. Instead of what you would have to do is you would have to, before we created a, what was the name of it? Times? I guess I can just go back. Yeah, so before we did square, we defined it once, and then we did square equals log of square. If we wanted to pass some arguments to log, we would have to do square equals outer wrapper function, inner wrapper function, square. I don't think I'm explaining it super well, but it gets really gross if you're trying to basically use this syntax without using decorators. I think that's about as deep as I'll go in there, but yeah. Questions on decorators, or more questions on decorators?
Do they pass code reviews?
Yes.
Nice.
Yes, it depends.
Especially if you review your code.
Yeah.
No, I mean, I would definitely say, like, depending on the decorator you're writing, if you're writing something like say a log decorator where I want to log, like Phil was saying, like, what the name of this function was, maybe how long it ran, that kind of stuff. Mm-hmm. Like, writing that inside your like user service, like that's doing some business logic with users, is probably not like the move. Then you're having like this business logic class, and then you have this like kind of multi-use decorator just thrown in there. Gotcha. And from like a code review standpoint, like your decorators, if they're kind of this multi-use thing where you could pass any sort of function to this like time it decorator, mm-hmm. Probably don't want to define it in like the same file as like your like some other random business logic. Is that, am I explaining that?
Yeah.
Okay.
I guess I was just wondering if it's like more of a convenience thing, like to help you debug and stuff, or if it's like you use it like big time in production stuff.
Big time.
Like, is this a common thing that you do with your programs you write?
It's relatively common. It's probably not a tool I reach for like every single day, okay. But especially when there's times where I want to have this reusable kind of logic that doesn't actually like so in the example we were using earlier, we were doing like GetUser, and that function encapsulates some like business logic to like go and get a user and do whatever and return it. Mm-hmm. And so timing how long that takes doesn't really have anything to do with getting a user. Like the idea of timing how long something takes to run is like you could use that in all sorts of different functions. And so creating a decorator to do that without sort of polluting that GetUser function, I would say is a pretty clean way of doing that. I mean, there's other ways to skin the cat, if you will, but that's a way.
So do you keep most of your decorators like in their own file that you kind of just import into the project, or?
Yeah, I think the ones that I use are usually in like some sort of like utility file or like a kind of a decorator specific module. Mm-hmm. You might consider, I don't know, depending how complex they get, you might maybe even if you have a couple really complex decorators, break them out into like separate modules. But I think having, like, I don't think most projects, like your kind of day-to-day project is going to have like dozens or even like 10 decorators tops. And depending what they're being used for, you might have them all in one file. It kind of depends. But.
Gotcha.
It's actually a good question. So when you're making your file structures, like what is it that like takes precedence in Python? So I know like in C# when you make a lot of files, typically it's like they're class files, right? You name them like after your class. You have a class in there, maybe you have like some subclasses related to that class, and then all your functions kind of sit within your classes. Mm-hmm. It's very object oriented. Mm-hmm. So in Python, when you're making like your file structures, what is it like you need in the macro, and like what takes precedence when like you're organizing those things? Because you said you have like a utilities file that
Yeah.
seems very generic.
Yeah. I'd say it kind of depends on the project a little bit, but I would say that coming from like C# and like TypeScript, I organize my file structure like organizationally fairly similar. Like maybe all my models are in like one folder, like services that are like kind of related for a project, or in like another folder, maybe like views or another folder. I guess I just kind of describe an NPC or something, but like I would say like from an organization standpoint, it's not that different than like a C# project or something. I mean, it's going to be like Python specific. Like you have to have a dunder init file in every folder that you basically want to be considered like a package or a module, so you can like import it. But that's just like a Python specific thing. I would say like organizing.
And the thing too, like when you're making functions, those don't necessarily have to be like within a class. Those can just float, right?
They can just float.
Do you typically float them? Like just let them float around, or you typically make classes to wrap them in? Like, is there a best practice there in Python?
I think it depends who you're talking to.
But I guess coming from C#,
For me, I
them.
think I definitely approach it from a little bit more of a heavy object-oriented standpoint. I say that the way I write a lot of my like services and stuff is similar in some ways, at least how I organize it, to what I was doing in C#. Things like creating like a class to represent like a user service that takes in a list of dependencies, and so when I can test that, I can pass in like mocks or whatever to more easily test it. I'm trying to think. There are ways in Python, like you don't have to do any sort of like dependency injection. You could have pretty much everything like top level, depending on the project. That's not really what I do. You can use this concept called monkey patching, which is doable in Python, where you can basically at runtime replace the contents of pretty much anything. So say I have a class that's GetUser, I could at runtime go in and reassign the GetUser function in my service to be some other function. So that's a way to approach unit testing, though I try and favor using like more of a mocking dependencies approach.
Yeah, I like the stuff.
Yeah. I think some people, especially people who probably doing Python longer, might do it a different approach, but
I have like this scale. I have the scale of PowerShell to C#. I'm trying to figure out where Python fits on that scale.
I think Python can fit
Those are the two
pretty
languages.
close to either one, to be honest, like
Yeah.
depending how you're writing it.
Yeah.
Python is everything. No, I'm just kidding.
Probably closer to PowerShell. Would be
That's what
my
it's
guess.
kind of
hurts.
making me think
It's
of.
it's a scripting language, right?
Yeah.
So whereas C# is compiled.
It's a
I guess
language.
in that respect, it's probably closer to PowerShell. But in other ways, maybe it's closer to C#.
You just don't want to be close to PowerShell.
I don't want to associate with PowerShell. That's okay. We're at 7:23. Any other questions with? Well, so here's if I defined basically a decorator that you can pass arguments to, and then I called square using two. You see that we defined it to print out 3 times. It's going to print out 3 times. The last thing, which I'm not going to cover because I did not finish the slides and we are running short on time and I don't want to go too late, is generators. This could probably be on a lot of these things that I've covered. I've kind of taken more of a wide approach than going particularly super deep in any of them, partially because my knowledge doesn't go like super deep in all of them, and partially because I wanted to more introduce like a pragmatic approach, like a bunch of different tools you can use. That being said, a lot of these kind of high level, I guess like bullet points or topics that we've covered could easily be their own meetup, their own Python conference talk, and most of them are, especially generators. I'll say this, generators are super powerful. They're basically, someone's going to point out how this is wrong, but they're basically how you implement coroutines, which is like asynchronous code. and generators are kind of a fundamental of how that works. But I'm not going to get into it, A, because I don't know all the details, but I will hopefully know for a future meetup. And B, because we're running a long time. Yeah, you can see this is where it was crunch time. And I ran out of time. I can show it. Yeah, we didn't cover testing. I talked about it. What's new in Python 10, async in Python. I guess testing in Python can probably be its own future talk. Real quick, I'll just show you guys two things. One is I will show you, I can't remember if I had, nope, didn't get to it. So a generator basically looks like this, user or user in user service list users, pretend that exists. And I'll just leave you with this and then we'll call it. The only difference here, sorry, that you initially see that separates it from a list comprehension is the use of parentheses instead of brackets. And you might be like, it's basically the same, like what's the difference? Basically, this turns this whole expression into a generator instead of a list. What a generator is that it's a piece of code that yields control basically for like each item. So in this case, like list users, I guess I can just write it down. Sort of would have something like yield user, and it's getting these users from wherever, it doesn't matter. But basically, this yield keyword basically says it's going to like spit out a user to the thing that's calling it, and then it's going to basically save where it's at in the function, like save the context of where it's at. If you say you had some like logic before that or logic after, and then it's going to be able to resume this function picking up where it left off. So say you had, I'm trying to think of an example.
So not blocking, building the list without blocking.
Exactly, yeah. And so this enables like two things. One, say you were trying to very poorly add up all the numbers between like 1 and 1,000,000 or something, or some bigger number that your computer couldn't possibly handle, like all of the numbers in memory. A kind of trivial or naive approach would be, excuse me, okay, I'm going to create a list with all these numbers, and then I'm going to add it all up. And then your computer like crashes because it runs out of memory because you're doing such a huge number or something that it runs out of space. But another way to do that is using, and that would be using maybe like a list comprehension or kind of a naive approach. Another way to do that is using a generator where you're basically, for each number in this list, you're keeping track of your kind of your running sum, and then you add the current number to that sum, then maybe you yield controlled, wait for the next number. When you get the next number, you resume your logic, you add it to your running sum, and then basically at that point, you only really ever have like two numbers in memory at once. You have the number you're currently looking at in your big list of numbers that are coming from somewhere, and then you have like your running sum. So instead of having like a billion numbers in memory at once, it's going to run into issues. You're just grabbing basically one at a time. And so it allows you to do things that you potentially wouldn't be able to do just based on like the amount of space it takes up. And then, as Phil pointed out, it's like, well, what did you say again?
Yielding, so
Yeah.
Asynchronous allows it to run, be interrupted and continue to run in the background.
It's not asynchronous, it's laziness.
Okay.
What is that?
What was that?
Yeah, and so I should say this. Generators are sort of they're not asynchronous code. They're like asynchronous code in Python is totally different. They are lazy. I don't know who said that, but it was true. So when I say that there's sort of a building block, for lack of a better term, of asynchronous code, is that they enable you to build something that functions like asynchronous code or is asynchronous code. They are not in and of themselves like asynchronous. So you don't like await a generator or anything like that. Good point, mystery internet person. Thank you. Cool, guys. I think I got one more slide. We have Craigslist up. So there's actually a code snippet, which I didn't go over today. But I kind of created a little last month we had created a kind of a command line Craigslist scraper where you could pass it a URL and it would go like scrape like the names of cars for sale and how much they cost. And I wanted to kind of put some of what I was talking about into actual code for you guys to be able to go and look at. So that will be available on the GitHub repo. We won't look at it today, maybe in the future, but that is available. And it kind of expands on that Craigslist scraper thing that we started building last month. Final thing is an anything but mundane intro to machine learning, coming to you in January from Clayton. I don't have a question slide, but thank you guys for coming. And if there's any more questions, feel free. But that's about it for today.
Thanks, Joe.